Good day, everyone. And once again, your favorite uncle is back, and we'll be looking at probability and obviously fundamental counting principles. So, if you haven't subscribed, please just do so, and please tell as many people at the end of this lesson. I want 1,000 likes at the end because this is quite a tricky section sometimes. At the end of the day, I'm trying to help you to just navigate through these sections so that you can get maximum results. All right, so let's get right into our question as you prepare for your exams. All right, so they say to us we've got two events, A and B, are such that so events A and B are independent, first of all. So please remember, once they are independent, it means in this case, the probability of A and B can be equal to the probability of A times probability of B. All right, we'll talk about that. So they say probability of not A is 0.4 and the probability of B is 0.3. Right, so they say calculate the probability of A and B. So remember, because they told us that these are independent events, so we know that if we set the probability of A and the probability of B, okay, rather the probability of A and B would be equal to the probability of A multiplied by the probability of B. Remember, these are independent events, so we can actually do this. And by the way, if you still don't understand this section, please go back to our teachings, the longer lessons that I had on this particular sections. Okay. Right, so I've got an entire playlist, by the way, of probability, so maybe have a look at that. So in this case, we said probability of A multiplied by probability of B. So we've got the probability of B, but we don't have the probability of A. But remember, they gave us the probability of not A. So we're going to use, in this case, our principle. So probability of not A, okay? So this will be the probability, or 1 minus rather, the probability of A, okay? Or we can put it the other way around, right? The probability of A is equal to 1 minus the probability of not A, okay? So this would be the probability of not A. All right. This is our complementary rule. I hope you still remember that. So it means in this case, I'll have 1 minus 0.3. This would give me 1 minus 0.4. That's the probability of not A. So that's 1 minus 0.4, which will give me 0.6. So it means now I can calculate the probability of A times the probability of B, because I've got both now. So this is going to be 0.6 multiplied by the probability of B, 0.3. And in this case, of course, 0.6 multiplied by 0.3, that should give us 0.18. Okay, right. So I hope you understood that. Okay, so remember our complementary rule. This is what it looks like. And in this case, it helps us to calculate that back. All right. Now, let's look at the next question. And by the way, that was only 3 marks, right? So, it is something that is quite sizable, right? So, in this case, they say the probability... Okay, I think I left out something. All right, a survey was conducted amongst 150 learners at a school. Okay, the following observations were made. They say the probability that a learner selected at random will participate in only hockey. Okay, so by the way, I want you to just quickly note that what they have there, they've also indicated. So probability of only hockey, that's 0.424, and 0.14, that's the probability of debating and hockey but not chess. So that's it there. Okay, and then we've got debating and chess, 0.12. So here it is here. Okay, and they said hockey and chess but not debating, 0.02. Okay, and they say the probability that a learner selected at random participates in at least one of the activities, okay, is 0.7. Now I want you to think about it. So it means that all of these learners within our sets, okay, in this case combined, should give us a total probability of 0.7. So that would kind of tell you what is on the outside, the probability of you not finding anyone that is not participating in any of the three, right? So remember, I'm trying to help you here so that you are able to, navigate and know how to interpret each one of these of this piece of information that's given. Right, now they say to us 15 learners participate in all three. So it means this would be the special group that's inside of here, right? That's the 15 learners, right, that participate in all three. But remember now, that's 15 learners out of the 150, right? Okay, and they said to us the number of learners that participate only in debating is the same as the number of learners who participate in only chess. So in this case, they've indicated that by that variable b there. Okay, right, now let's try and answer the questions. They've given us a Venn diagram. So that's our total sample space. All right, so let's start there. They say determine the probability that a learner selected at random participates in all three activities. Now, of course, we've just shown you this. In this case, how would that look like? Okay, so that would simply be the value of A, which would be, we know we've got 15 learners that are participating in all three out of the 150. All right, and of course, that will give us 0.1, I believe. Okay, so that's 15 divided by 150, and that's 1 over 10, which is 0.1. Okay, right, so that's our value for that. Okay, they say determine, in this case, M, the probability that a learner selected at random does not participate in any of the three activities. Now, remember, so we're going to use now, okay, let me just label these. Okay, we're going to use our complementary rule in this case, right? So what are the probabilities that they at least participate in one? It's 0.7. So it means that M would actually be 1 minus 0.7. Okay, this is for 1 mark, ladies and gents. So so that would be 0.3. So it really does not, you don't need to invest a lot of time here. Okay, I hope that makes sense. Okay, so the total number of learners that are participating, well, not number, rather, probability in this case would be 0.7, isn't it? All right, now they say how many learners play only chess. Okay, so which means, what are we looking for? We're looking for B, that value there, right? But remember, B is also the same value that learners that are only doing debating. Okay, so what I'm going to do is, let's find the sum of all the probabilities in our sample space. And in this case, I want you to note, what is that going to give you? It's going to give you 0.7. Okay, because that is what was given to us. Okay, sorry, I'm trying to just remove this so that we can see. All right, now for 11.3.3, so I'm trying to actually 0.2.3 rather. Okay, so we're going to say 0.24. Okay, so that's 0.24 plus 0.02 plus 0.14. Okay, so I'm just simply taking the sum. Okay, plus 0.12. I think I've added everything, so that's 1, 2, 3, 4 numbers. Okay, plus A, by the way, which is 0.1. plus that 0.1, plus B and B, so that will be 2B, right? This is all equal to 0.7, okay? So let's add all of those up. So we said 0.24 plus 0.02 plus 0.14 plus 0.12 plus 0.1, okay? That gives us 0.62. So 2B is 0.7 minus 0.62, which will give us, okay, that will give us 0.08. Okay, so 2B is equal to 0.08. So meaning B, what we'd just simply do is just divide everything by 2, and then B would be equal to 0.04. Okay, now we must be very careful here. They were not looking for the probability of learners that are playing only chess, but they are looking for the number of learners that are only playing chess, right? So what we're going to do is that we're going to take that probability of learners, and we're going to multiply it by the total number of learners, which is 150, right? So in this case, it means I'm just simply going to take that 0.04 and I'm going to multiply that by 150, okay? Multiplied by 150, and that will give me, so it means that it's going to be 6 learners, okay? So that would be the number of learners that are playing only chess. And by the way, remember that would mean for the only those that are doing what is that, debating, okay? Right, hope that made sense. Okay, let's try to move this down a little bit so that it just becomes easier. All right, now we're getting into fundamental counting principles. Okay, and by the way, this is not such a bad section. As I said again, you know, I've got 3 lessons, okay, a series of 3 lessons that I've produced there. Please have a look at it. You'll see that it becomes something that is quite, well, I won't say easy, but it's actually possible to actually understand it, okay? Right, so they say to us a 3-digit number is made up of by using 3 randomly selected digits from 0 to 9. So, you know, I actually prefer to always, you know, just try and draw, you know, what I'm looking at here. So I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we've got 10 digits in total, right? Now, they say to us we need to make a 3-digit code, and they say no digits may be repeated. So that's very important, right? So I want you to look at this. Now, they say determine the total number of possible 3-digit numbers greater than 100, okay, that can be formed, okay? So first of all, right, so it means that how many digits are there? So I'm making a 3-digit code, okay? So I'm making a 3-digit code. Now, for the first digit, okay, remember it must be greater than 100. So it means I may not select 0 for the first digit, right? So how many possible numbers do I have? I've got 9, right? So in this case, that would be 9, okay? Now for my second digit, you must keep in mind that in this case, I may not select the number that I had there. So that would be 9 times, in this case, I've already taken one of the digits, right? In this case, and by the way, this time around, I may include 0. Remember, I'm looking for a number that is greater than 100. So I may include 0 here, but I've already taken one of the digits. So how many am I left with? okay, I'm left with 9, okay. That is inclusive of 0 this time around, okay. Now, I've taken 2 digits, right? So I need to pick another one there. Of course, how many am I left with? I've used 1 here, I've used 1 here. Of the 9 that I had, remember, okay, now I'll be left with 8 digits. So in this case, that would be 9 times 9 times 8. I hope that makes sense, ladies and gents. Okay, so in this case, I'm simply going to say, remember, for this third digit, I could also choose 0, right? So that would be 9 times 9 times 8. And so that gives us 648. Okay, so the number of digits that we could form is 648. Okay, right. So the next one, they say determine the total number of possible 3-digit numbers, both even and greater than 600, that can be formed. All right, now this one just slightly on the tricky side, but you'll see as I do it. Now, I want you to think about it. Okay, we're forming a 3-digit code. Okay. Now, we want it to be even, right? So remember, in order for that number to be even, it means this number here must actually be an even number. Okay. Oh, and by the way, it should be greater than 600. So it means that for our first digit, we can only select from these 4, right? Now, there's a bit of an issue because now there are 2 possibilities. If for my first choice I choose an even digit, okay, then it affects the numbers that I would have. So in this case, let's say if we started with an even digit here, right? So in that case, what would happen? We know we're supposed to have an even digit there, right? So if I took an even digit for my first number, that would be 6 or 8, right? So in that case, how many numbers do I have? I've got 2, right? That I could use. But now, remember here, I can actually choose any number. But remember, I need to choose an even digit there. So how many do I have? Okay, I could select from 0, 2, 4, 6, or 8. But remember, I've already taken 1 from that, right? Between 6 and 8 in this case. So it means how many do I have? I've got 4 that I can actually select from. I hope that makes sense. Okay, so now I've used 1 digit here. I've used another digit here, right? Out of the 10, how many do I have left? In this case, remember here I can select any of the digits. So how many do I have left that I can use? I've got the 8. So it means the first possibility is if I choose an even number, so that will be 2 multiplied by 8 multiplied by 4, right? But if I choose an odd number, now let's take another possibility now, a 3-digit code. If I take an odd number there, right? Remember, this number still has to be even, right? In order for that digit to be an even number. So it has to be greater than 600. So now I'm looking at between 7 and 9. Those are my odd numbers that are greater than 6. Okay. So it means that I've got 2 that I can select from my first digit here, right? Now, in this case, let's come back to this guy. So it has to be an even number, right? But remember, I've already chosen an odd number there, so it wouldn't affect the number or the even numbers that I have. So I could have all 5 of them, right? Because I've chosen an odd for my first number, so that would be 5. Okay, so remember, I could choose any of the numbers here. I've already taken 1 digit here. I've already taken another digit there. So in that case, that would be, how many numbers would I have here? I would have 8 that are left. So in this case, it means that that number would be 2 times 8 times 5. So it means the total number of possibilities in this case will be this one, the possibility that I choose only even numbers. Okay, the first digit is an even number, and then the possibility that the second number is an odd number. Okay, the first digit rather is an odd number. So in this case, what will I have? I'll have 2 times 8 times 4 plus, okay, that's another possibility. That's 2 times 8 times 5. Okay, so in this case, I've got 2 times 8 times 4, okay, plus 2 times 8 times 5. And that gives me a total of 144. I hope that makes sense, ladies and gents. That would be the total number of possibilities that we'd be looking at. All right, and we have come to the end. I hope you've watched all the, question papers that, or rather the questions that I've done for this question in particular. We started from question 1 right up until, question 11, and hopefully they were able to assist you. All right, so please, if you haven't subscribed, please just hit that subscribe button. We are working towards 100,000 mark. Hopefully we'll get there with your help. Okay, and your favorite uncle will see you, and please keep working hard. Sharp, sharp.